Let's see. All right. So is it possible to recognize a support and resistance cluster area? Like if a VWAP and 2D VWAP, 2 standard deviation VWAP, I guess. Let's see. Yeah, so I guess we have a VWAP and then, I don't know, some other support resistance line. Yeah, so can we identify a cluster? Yeah, so we have a VWAP with a daily VWAP and yesterday's value. Yeah, okay. Yeah, that should be, yeah, that's pretty simple there, Vito. Let's use the super trend indicator that, since I already have that on the chart, and we'll combine that with just an SMA, Yeah, so let's just take just 2 indicators, even though they're not support resistance, but, the thing is, the question really boils down to, can you identify a clustering of 2 different indicator plots, in close proximity? Really what the question boils down to. So we want to identify, right, when one indicator plot is in close proximity to another indicator plot, right, like so. And that is a simple matter of using a comparison solver. So let's make a new logic template here. All right, so a cluster example here. So we're going to go to our solver nodes and go down to the comparison solver. Let's connect that up. And so let's see. There. All right, so I got a name for this thing, calling it the SMA 50 and the Supertrend M11 cluster. So for input A, let's put in the SMA 50. So let's just change the period to 50 there. So there's our SMA 50, and input B, we'll put in the Supertrend M11. So let's go to our Lizard indicator folder, scroll down to the Supertrends. So there's the M11. All right, again, I'm just using the default Supertrend settings here. And so with the comparison solver, the key to identifying a cluster is, for your outputs, you want to use A equals B. You want to use that output right there, right? For both the long and the short. And then, for the proximity of them together, well, that is where you decide what the difference should be, right? So for the large amount and the small amount, you have to decide, how close do those 2 indicator plots need to be considered a cluster? So what is your preference here? Do you want to use points? Right, so is 1 point close enough? Do they need to be really close? 1 point. And let's see here. Wow, actually 1 point is, I guess, quite a bit. Maybe half a point, something like that. There we go, half a point cluster. So there we go. They cluster together twice, right, with half a point. Or do you want to use a volatility-based measurement, such as an ATR? Maybe, let's see, what do we got here? Half an ATR, right? So, right, so the key here is you want to use A equals B, and of course you have to make a comparison solver for every combination of plot lines that you want to find a cluster for. So you'll probably have a whole bunch of comparison solvers, comparing the different VWAP lines with other, support resistance indicator lines. So however many combinations there are, that's how many different comparison solvers you're going to need. And then you just need to go in and set up the the difference, for whatever proximity you want. Right. So right now I have A equals B within half an ATR. Right. So there you have it. That's one example of finding a cluster. Right. And then if you have, a bunch of comparison solvers, well, it depends on how you're using this within your system, but most likely if you need to combine those clusters together, then you probably want to use an OR node. But I can't think of a practical way. I can't think of a practical reason why you would combine all those cluster, comparison solvers together. So anyways, I'll just, we'll just leave it at that. So, all right, so that was Vito's question. Pretty straightforward there. Vito was saying pivots. Yeah, you can use whatever indicators, you want in the comparison solver.